DNS is a particularly common source of latency. You are trying to resolve multiple host names to reach a SaaS, a cloud, a CASB. That applies to everything. And on that host name, you get an IP address, and that IP address is going to change through time. That IP address is going to change depending on your ISP. It's going to change depending on your location, and that's going to be dynamic. So the first thing you need to understand is whether that redirection takes you to a place which is narrow enough to provide a good latency or far from where you are. So if I take examples, I remember people having trouble with their CASB, depending on the ISP, being redirected not to the local node of the CASB, but being redirected to the West Coast, and then trying to make their way to Europe. There's no network problem in that. Actually, the network works as expected. It's just that the path is very long. Yeah. And the resulting experience is dreadful. So that's number one. The second one is the ISP performance and the BGP routing. So it's all about what is the quality of the connectivity that my ISP is going to provide to that destination. What is the route that I'm going to be taking? And that's driven by BGP, the protocol that drives how internet flows are routed through public networks. And here you can find plenty of different consequences. Either the path can be abnormally wrong or non-optimal. You might find that some devices on the way are not performing as expected, and that can result in a bad path, some additional latency or added packet loss on the way, which is going to penalize any application going through that route. Okay. The third one is CASBs and cloud proxies. You've got to think of CASBs as an additional node on the path, but CASBs have all the bad characteristics of any cloud or SaaS platform. They redirect you to a place. That place might be the right one, might be the wrong one, and they have a processing time, so they might have delay on the way. And it's important when you choose a CASB solution to understand whether their capillarity, so how distributed they are, offers the right service for all of your users, depending on where they are located, which ISP they use, and so on. And I guess it's very important to measure that, because you might find that some CASBs do not have a good coverage of a certain region, actually have a longer latency from your users to their nodes, or simply have a much slower processing. And all three reasons will have very big latency, additional impact, or added latency. The fourth one is SD WAN underlay path changes. When you use SD WAN, okay, you can switch from one underlay to another. That has an impact, but each underlay has got its own behavior and can change paths on the way, and that can drive to packet loss, that can drive to bad paths. And the same thing applies to CDN. SaaS platforms that you use are going to use CDN networks in principle to make the content close to your users, but sometimes it just doesn't work as expected, and you might end up having a long path to a CDN, and that will have an impact. The sixth one, we've got to remember that although we go through the internet, the local networks also have a huge impact and have their own issues, and Wi-Fi is one of them. And we find that sometimes the Wi-Fi coverage is just not right. Sometimes it just doesn't work as expected, and it's important to identify that this might be the cause of a bad experience for your users. And the final one is cloud network path length. So again, a cloud is just not one hope. I'm in the cloud, next hope, I reach my application. You might find that sometimes you've got 10 nodes on the way, and sometimes you may just go across the pond through the cloud network.